So let's have more questions on collision. So consider an elastic collision head-on between two balls of different masses. They have different masses here, 3.6 and one has 1.2 kg, shown in figure. The mass of ball 1 is 1.2 kg, its velocity is 7.2 meter per second westwise. So it is towards the left. And the mass of the ball 2 is 3.6 kg. The ball 2 is initially at rest. So the initial velocity is 0. So we'll do a problem similarly as we were doing. Let me have some space. We need to find the final velocities. So we'll apply conservation principle first. So conservation principle, let's apply that of momentum. And that says the initial momentum of the system should be equal to the final momentum of the system. So what will be the initial momentum? The P initial will be equal to, so remember M1 is this one, so 1.2 multiplied by, this is going towards the negative side, so I have to factor in this direction. Remember that whenever we are applying conservation principle of momentum and we are putting values, we have to take care of directions. You can't deny that. Remember that. So that will be the this guy's initial momentum, and what will be the initial momentum of this? This will be 0, right? The m1 into 0, it is at rest, we know that. So let me calculate that. 1.2 into 7.2, that will be 8.64, and that will be negative. So what I did, last time when I was solving this, I just take positive value 8.64. Everything I did right, but this small mistake costed me and I was not able to get the answer. So remember that negative signs are very, very important when we are doing these kind of calculations. Now let's go. What is the final momentum? Final momentum we don't know actually. We just know the masses. So m1 1.2, vf1 final of 1 plus 3.6 into vf2. Yeah, and that has to be equal. Let us apply this formula. So minus 8.64 should be equal to 1.2 vf1 plus 3.6 into vf2. So this becomes our first equation. Now we can apply our fact, the shortcut, which we use, that the velocities will be equal. Their addition will be equal in case of elastic collision. So that will be like v of initial of 1. If you add that final velocity of 1, that will be equal to v initial of 2 plus v final of 2. So this is our second equation. We have to make this. So I will put values. So v initial 1. So remember, this is initial 1 I'm taking. So that will be having minus velocity, minus 7.2. Initial velocity and the final velocity we don't know. So I will just write it like that. V initial of 2 is 0. It was at rest. And V final velocity, we don't know. That is what we want to calculate. So I will call this as second equation. Let me drop this. So this is my second equation. I will still simplify it. Wait. So I can say VF2 will be VF1 minus 7.2. So this becomes my second equation. Now it is a question of how to solve these two equations. They have two variables. We can put VF2 here, here. Instead of that, we can put this. So let me solve further. So I will say minus 8.64 is equal to 1.2 VF1 plus 3.6 into VF1 minus 7.2. Here is the replacement. And now going further, 1.2 VF1 plus 3.6 will go inside, 3.6 VF1 minus now 3.6 multiplied by 7.2, and that will give me 25.92. Now I'll take it this value that side, so it will, we can reduce, and this the minus value of 8.64. Let me calculate straight away that. So that will be 17.28. 17.28. That will be our, let me add these two values also. They are having the same variable. So that will be 4.8 VF1. I just need to divide this. right? 17.28 by 4.8. So divided by 4.8, and that is 3.6. VF1 is equal to 3.6 meter per second. So can I calculate VF2? We can. We can use this equation. So I just need to, you know, put 3.6 here. 3.6 minus 7.2. It is half of it, so it will be minus 3.6 meter per second. So they are going with the same velocity but in a different direction. So the the final result, if you see, so this was M1, this was M2. So M1, the mass 1, will go in the positive direction. Positive direction is this. So M1 will go like V final is this one, right? Positive 3.6. And VF2, this guy M2, this will go in this direction with the same speed of 3.6 meter per second. We can put a negative sign here if we want to show the the values of this one. So this is our final answer for this. Let's do another question. Here is a car ride. Bumper car 1 has a total mass of 350 kg and it is initially moving at 4 meter per second eastwise. So east means right side. So I will just put some mass here. So it is going this side with a speed of 3, sorry, 4 meter per second. 4 meter per second. And the other car is moving this side. The elastic collision happens. Bumper car 1 hits bumper car 2. The total mass of bumper car 2 is 250 kg. So this is 250 kg. Let's say it is M2. This is M1, which was 350 kg. And this was moving 2 meter per second towards this side. 2 meter per second. 2 meter per second. So it is going westwise or left side. So now we need to find what is the final velocity of each bumper car immediately after the collision. So the first thing which we'll do, conservation of momentum. That will give us one equation. Let's get that. Conservation of momentum. So what will be the initial momentum? This is 350 and it was moving towards right. I will take right as positive, plus this was moving 250 m2 mass. It is moving minus 2. I will take consideration of minus always when we are calculating the momentums. So let me calculate that. It is 350 into 4 minus 250 into 2, 500. That will be 900 kilogram meter per second. What will be the final? We don't know that. We just know the masses. So let's plug in that, which we know. So which this is the final velocity of 1. And this is M2 into final velocity of 2. And that has to be equal. So let me write equation. 900 should be equal to 350 VF1 plus 250 into VF2. So that is our first equation. Second will be the shortcut, the fact that the velocity additions will be the same, or the V initial of 1 and V final of 1 will be equal to V initial of 2 plus V final of 2. So what we know the initial velocities of 1, and that is positive 4, sorry, 4. VF1 we don't know. VI2 we know. Initial velocity of 2 we know, that is minus 2 plus VF2. We don't know the final velocities, right? So I will take this other side and I can say VF2 VF2 will be equal to whatever the VF1 is, just need to add 6. So this becomes my second equation. Now we just need to solve these two equations and we can, put value of VF2 here. And that's what I'm going to do. So 900, 350 VF1 plus 250 into, can put VF1 plus 6. So now 250 into 6 will be 1500. So let me 350 VF1 plus 250 VF1 plus 1500. And now I will take I can add them up, these things, and I can take this 1500 other side, it'll be the negative sign, and I can subtract 900 from it. So that will be minus 600. Minus 600 will be equal to, I will add them up. So it will be 350 plus 250, it will be 600 again, VF1. Cancel it out. VF1 is 1 meter per second. Remember the negative sign. So that you need to be careful. So this will be minus 1 meter per second. Okay, so I can calculate, use this equation and do it the VF2 calculation. So VF2 will be, we have to add the 6 with it. So minus 1 plus 6, that will be 5 meter per second. So how our cars will be after the collision, just after the collision. So this is my car 2, this is car 1. So the VF1 is going minus 1. So it is going like this in this direction, minus 1 meter per second. And this guy is going in this direction. Let me put a bigger arrow because the velocity is more here. So this will go 5 meter per second, and that is natural because this has less mass. So that it had got more velocity, we can say. So this way we can solve these two additional questions also.